I come with problems, but probably I don't come with the solutions. I hope that this presentation is so good that you appreciate it being done twice. But the air pollution everywhere all the time, it's always been that way. It's been that way since mankind started using fires to cook meat, to make things more digestible, to give warmth and comfort. And the reason for putting this in is not to give you a history lesson, but to remind you that fire is quite central to our lives still. And the behaviour change that's going to be required to wean us from these kind of carbon-based fuels is going to be quite big, because it's so ingrained in our society. And has been for some time. This was Claude Monet's picture of the Houses of Parliament in 1901. And you either say that this is blurred because he was an impressionist painter, or because he was towards the end of his life and he had cataracts, which are both true, or there was a lot of smog in London at that time. And I think it's probably the latter. It's been going on since the Industrial Revolution in the UK for sure, and it's got worse. It got worse in the 1950s, and this is lacking colour and also lacking definition because of the smog in front of the London bus in 1952. And this gave us some very good empirical evidence that high concentrations of particulate matter led to respiratory illness. And you see, this is December 1952. And you can see the squares here are sulfur dioxide, which was the most conveniently measured particle at the time. And you can see by December 4th onwards, they've started to go up. There was an inversion layer, there was a cold amount of air that stopped air moving, there was a lot of industry in the middle of the city, and sulfur dioxide and probably all the other particulate matter that we know of went up. And then a few days later, this is admissions to hospital for respiratory disease started to climb. There was an acute change in people's respiratory disease. And there was an acute change in their cardiovascular disease, people presenting with myocardial infarctions, which suggests that this is not just a one system disease. We know this now, but this was the first time this was shown. This is acute. What was interesting is that there was a flu epidemic at that time, and people felt that the later deaths, those that occurred, and there was 8,000 excess deaths in the new year of 1953, must have been attributable to influenza. And influenza was the sequelum of this high particulate matter in December. But that's not the case. Recent reinterpretation has shown that the excess deaths tended to be associated with COPD and other chronic conditions, but there was a huge number of unexpected deaths that weren't due to the influenza at the time. So this happened months down the line. So acute exposures cause injury and death to the lung and cardiac function at the time, but also protracted problems, and I'm going to show you even later. This, of course, didn't end in London in 1952-3. This is the Bird's Nest Stadium in the Beijing Olympics just prior to its opening in 2008. And we know the problems that China has with air pollution, but I'll talk a little bit more about that towards the end. We know what bad air quality is. Wolfbringa suggested that you know Uganda has air problems, or at least Kampala does. Chamoliwa was very nice yesterday. I came back to Kampala and realised exactly how bad the air quality was. But what's good air quality? There's so much evidence here I can't present it to you. But I'm going to show you one paper. And this is one of my favourites because it's historical 52 cities in the US with very good monitoring, and showing how over the ensuing 3 decades, the time-weighted average of your particulate matter can change your life expectancy. This is in a high-income country. This is the PM 2.5, the annual time-weighted average, and this is life expectancy. And there's problems with this kind of data. Each of these points is a city, and there's been lots of adjustment for socioeconomic and socio-demographic features. But the conclusions were, and it was fairly robust, that if you reduce your particulate matter 2.5, so that's the smaller particulates, less than 2.5 microns in diameter, by 10 micrograms per meter cubed, over the course of the year, you live longer, to the extent of 7 months longer. What I'd like to draw your attention to is the numbers here, and they may not mean anything to you yet, but I hope they will. 10, 20 and 30 micrograms per metre cubed. How we measure air pollution depends, as I've talked about, whether it's acute or chronic. This is the US Environmental Protection Agency's suggestion for acute exposure. They come up with an air quality index that's an index derived from the commonly measured and difficult problem-causing pollutants: ozone, 2.5 and 10 particulate matters, carbon monoxide, sulfur dioxide, and the nitrous oxides. And you can see that when the AQI is above 100, sensitive groups, those with COPD, the elderly, children, start to be affected, and the advice is that they should stop exercising outdoors for long periods of time. As it rises, it starts to affect people that don't have underlying conditions. So it suggests that there's sensitive groups, but everyone is sensitive. And by the time this comes to 200, everyone should be staying indoors and not exercising outside. This is in the acute setting, the equivalent of a smog. But those numbers that I talked about, the 10, 20 and 30, relate to the same scale as the WHO air quality guidance, where the annual mean 2.5 particulate matters should be less than 10 micrograms per metre cubed. You can see that was well to the left of that last graph I showed you. So what's it like in African cities? I'll show you some more data globally, graphically in a minute. So the blue is PM10 and the red is PM2.5, and you are here with the WHO and other reference ranges for OK air quality here. And this is reflected across a lot of African cities as they commercialise, industrialise, and often because of a lack of stringent domestic legal restriction on their expansion. This is it done as a graph. So this is a modelled, a geospatial modelled territory. This is now, the red is over 35 micrograms per metre cubed. And you can see a lot of Western and Sub-Saharan Africa just through the Sub-Saharan African belt and down to include Uganda is really in that highest category. And that belt runs across, including India and certainly the coastal parts of China. That's where the PM2.5 is worse, at least it was 2 years ago when these data came from. And I've shown this graph before. This is a satellite composite image of the Earth at night time, taken at different times and then sewed together. And you can tell what I'm going to do next. This is where people turn on the lights. This is where people have electricity. And this is where people are most exposed to air pollution. Places that do not have a lot of electricity, for the most part, have higher exposures. There's a lot of missing data here, but in essence that's true. And I'll come on to household air pollution in a minute. This is indoor and outdoor air pollution, because of course they come from different sources. This is the number of DALYs, the number of disability adjusted life years lost to high air pollution. And there's a lot of missing data here. Uganda is relatively less problematic than Sudan or Nigeria. What I might point out to you is that India and China, that have relatively similar populations, these are not population weighted, India has a much worse problem than China. And again, I'll come back to that. But the Health Effects Institute suggested that exposure to air pollution, on average, any child born today will reduce their lifespan by almost 2 years. What's affected? Well, this was a recent review in Chest earlier this year, and the question is what's not affected? Of course, these are all epidemiological associations, and a lot of the underlying science might not be so down quite, but we know specifically that strokes, that acute and chronic lung problems, and a number of other cardiac issues somewhere else are all affected. And that's just the non-communicable disease. This is before you start talking about excess pneumonias and other things. All of these organ systems are affected. And why are they affected? Well, when you ask a lab scientist why things are affected, they will start talking to you about reactive oxygen species, about inflammatory pathways, because in some ways these are the easy things to measure, and they're also the things that get you into journals. But particular exposure from the ambient air enters the lung, and the coarse bits, or the bits that are over 100 nanometers in diameter, stay in the lung and cause problems there. They generate reactive oxygen species, they're pro-inflammatory, they alter cell signaling. Very small particles translocate across the epithelial barrier into the rest of the circulation, causing vascular dysfunction and broader effects in the circulation and heart. And if I tell you that people currently think that all these organs are affected because of these inflammatory pathways, it won't be long before someone suggests that what we really need to sort this out is a statin. And in fact, people have suggested that what middle-aged women need for air pollution is a statin. I'm not going to suggest that, although there is epidemiologic evidence that it might reduce the risk. There's probably a more direct way of doing it. So household air pollution then, that's a big thing here. And it's a big thing across lots of sub-Saharan Africa and in Malawi, where I spend most of my time. And these are data from a large cross-sectional survey of particulate exposures and carbon monoxide exposures from a randomized control trial I'll talk to you about in a minute. And what I'm showing you here is an agreement between the first part of our monitoring, the first day, and the second day. Individuals, when you monitor them for a day, that seems to be fairly representative of their life. Rebecca, in her project in Impala, is trying to measure this over even longer periods of time to be even more definite. But we're quite sure that particulate matter one day is quite well correlated with particulate matter the next, because people's circumstances don't change. And that's true of carbon monoxide as well. So both of these are measured. This one is measured by shining a laser and seeing how much dust or other particles interfere with it. And this one is associated by electrochemical effects worn on the person. And again, if you measure it once and measure it twice, there's a good relationship. The problem is when you come to measure that against that, so particulate matter here and carbon monoxide up the y-axis, there's not the same degree of correlation, in fact almost none at all. So people are very uncertain what we should be measuring to determine people's risk or what we can do about it. Even in this day and age when we can do that. A long time ago, my supervisor, current supervisor, and one of his PhD students started measuring particulate matter in people's homes, shortly after it was done in Kenya for the first time, I think. And this shows particulate matter 2.5 over time. And this is a course of a day where the, not sure what you call it here, but mbola or jiko is lit for breakfast and then for sometimes lunch and then tea. And the concentrations within people's homes are huge. This says 0.25, but on the scale I was talking about earlier, that's 250. Okay, so these are huge concentrations, and it clearly has potential to be a big problem. And when you measure it, again, this is probably, the red line is where you want to be, both in the rest rule fraction and the total fraction. Concentrations are high in both urban and rural areas. Urban areas in the darker here, and rural areas where you might expect higher concentrations of household air pollution. But it's difficult to measure exposure, but it's certainly high. So what are the effects on acute lung disease? And the reason I bring this up is that a lot of the mathematical modelling now about the effects of air pollution due to household air pollution rest on this and a number of very other small studies. This was a landmark study by Majid Azati, and this was done in Kenya in 2001 and got into the Lancet because it was so novel, because he showed, both in children and in adults, a dose-response relationship between increasing exposure and the number of weeks or the fraction of weeks that people had acute respiratory infection for. Okay? This again was cross-sectional, it doesn't determine causality, but it was pretty good at showing that dose relationship. But a very small series, and this was household air pollution. What about acute pneumonia in adults? Well, more recently there's been more data, and this is a systematic review by Hannah Jerry, also from our group, And you can see exactly the data I just showed you on the last slide occupying a lot of this. And then a lot of other work, considerable in China, and then also through parts of Africa and South Asia and the Americas. But essentially, overall, there's not very good evidence of acute respiratory infection due to household air pollution. There clearly was with the smog. It's reasonable to expect there is, but there's not very good observed evidence of it. What about chronic lung disease? Well, I'm going to show you a few slides. A lot of data has come out of this centre, and this is cross-sectional surveys of chronic lung disease, chronic obstructive pulmonary disease. And this is the BOLD study in Cape Town, which showed in males and females a considerable amount of obstruction. This is a city where lots of people smoke, where there's lots of different sources of particulate matter. And this is other cities that were involved in the same study. Cape Town, I think, was the only part in Africa in this first BOLD group. And they showed both a lot of obstruction and a lot of restriction, small lungs. Was that due to air pollution? We should look somewhere else. Let's look in Uganda. And this is a fresh air study. So high rates of obstruction and relatively lower rates of smoking. So maybe that suggests something here. Females, you see, slightly more affected than males, as we might expect if females do most of the cooking and are most exposed to household air pollution. Not the same in Rwanda, and the picture is all very muddy. Which brings me on to two larger studies. You have contributed data to from Uganda, and the two studies I should point out I'm going to talk about look at self-reported household air pollution exposure and the odds of COPD. So do you get chronic respiratory disease if you know you're exposed? And this first paper in the same episode, the same journal, suggested odds ratios of 1.5 or something for COPD, and that worked across the board, higher in women than men. Didn't seem to matter very much whether you smoked, and there were some slight unusual things in that people with a higher level of education had a higher likelihood of COPD. And then the same journal published a paper that said almost the exact opposite. This is the BOLD study in a reanalysis, which you can see none of these odds ratios for either obstruction or restriction in women or in men showed any association between reported household air pollution and COPD. And so, March 2008, one journal said participants with household air pollution exposure were 41% more likely to have COPD, and approximately 14% of COPD in these settings is a result of household air pollution. And the authors from the other paper in the same journal said airflow was not associated with self-reported use of solid fuels from cooking and heating. And they questioned the extent to which high morbidity rates related to COPD in low-income countries are explained by the solid fuels for cooking and heating. And John Barnes, a good colleague of ours, suggested in an editorial this was a riddle wrapped in a mystery inside an enigma. And it may be. What are the options? Well, it might be that self-reported household air pollution is just not good enough, and I think that's what I'd argue. It may be that all this is confounded by poverty, and that particulate exposures don't necessarily matter, but something else does. Very difficult to entertain a study that would alter any of those things. But what about the interaction of acute and chronic disease? So if you can't show one of them very obviously, or the other, then you might look at the interaction. And this is Hannah Jerry's work again. This is looking at a case control study of people admitted to hospital in Malawi, in urban Blantyre and suburban Blantyre, and looking back at them and the controls after they were discharged following treatment for pneumonia. And what she showed was, when she went back into their homes and measured household air pollution, knew they'd had pneumonia, tested a control who they knew hadn't had pneumonia, who was geographically, sociodemographically and age related, couldn't spot any relationship between their exposures and the likelihood of pneumonia. But of course you could, and you might have predicted, that chronic respiratory disease gets worse and gets admitted as pneumonia frequently. And that's true both in the HIV positive and the HIV negative subgroup. But you can see, the reason for showing you this is that where you have HIV, there's a significant relationship between chronic respiratory disease and admissions. So you may or may not think it's important. I think when I go into someone's homes and my eyes start stinging, it must be. What can we do about it? Because there's plenty of good reasons to do something about household air pollution, even if it's not the health effects. We might talk about that a bit later. So the first study was the Respire study, and this was a improved cook stove in Guatemala. So instead of cooking on 3 stone fires, there was a plancha stove with a chimney, and it was quite high tech for the geography, and it looked to see if you randomised households to have this stove, was there a reduction in pneumonia? And the answer was there was no reduction in infants or young children in terms of the pneumonia, but there, on sub-analysis on secondary endpoints, there was in physician-diagnosed severe pneumonia. But this graph at the bottom shows the modelled relationship between the carbon monoxide exposure of the child, because they very well decided they were going to monitor the children's exposure, and the risk of pneumonia, physician-diagnosed. And the problem is the scales, because, as I said, you can't necessarily relate one particulate matter to carbon monoxide to another. But you can reduce your carbon monoxide dose quite a lot without significantly affecting your the odds of your pneumonia. And it's only when air quality becomes really quite clean that you start to see those improvements. So perhaps it was that the stove was good but not good enough. So we had what we thought was a really good stove. Again, it still used solid fuel, but it's a turbine-based thing. This is the Philips one, and it has a USB port so you can charge your phone, which is thermically generated. It has a knob so you can change the amount of air going through the turbine, and it really efficiently combusts wood, food residue and other things, and probably reduces particulate emissions from the per fuel about 80%. So Kevin Mortimer decided that he was going to do a cluster randomized control trial of this in rural Malawi. Again, using IMCI as the pneumonia diagnosis of choice, and giving these out and watching 10,000 child years of follow-up. Huge effort, but non-significant effects on either IMCI diagnosed pneumonia, hypoxic pneumonia or death. And a disappointing rate ratio. Again, why was that? So we tried again. I say we, this is other people now, this is Ali Lee and others in Ghana, in the GRAPH study. And this has not been published yet, so I'm showing you something that relates to the study but isn't the main outcome. This is an LPG intervention, so this is in relatively rural regions, people having heavy cylinders but clean fuel, relatively clean fuel, and it's almost 1,500 mothers. As I say, I'm not sure why they haven't presented the primary data first, but you might imagine why that's the case. This is looking at prenatal carbon monoxide as measured at the mothers and the infant lung function, and it's quite suggestive. This is respiratory rate and this is sort of tidal volumes over time, that the carbon monoxide does affect your lung function of your infant. So mothers exposed to carbon monoxide then give birth to infants that have problems. And I say that for the benefit of Rebecca, because I think she will be able to add a lot of light to this in her cohort study. And also that raised respiratory rate at 30 days was associated with increased pneumonia. Did the stove work? I don't know, but I will tell you when I do. But there are many ways to make air quality bad, and many reasons to improve it. And I think stoves are great if they have an overall benefit to the individual. Stopping smoking, we all know about. Urban pollution, the use of the kind of fuel you might use. There's wood burning to regenerate the soil. There is incineration of rubbish in the street, which is a big problem in Malawi. And there's reasons to improve it. This was rural Malawi, Chikwawa, in the floods of last year, which was much less affected than areas of Mozambique, but caused untold damage and suffering to people as a result, probably of deforestation, climate change, and our inability to get on top of this problem. So there's lots of reasons we should do something. And the reasons are that we think this affects, I've suggested it affects neonates, but this is a study now that goes back over 30, 40, 50 years of follow-up in Tasmania, where there's very good records of people's lung function over time, when they were 7, when they were in their mid-teenage and then teenage years, and when they were much older adults. And what you have to imagine is that people have been coded at the time they seen into adulthood as either being unaffected, as having asthma, COPD, or both. And you can see, for example, this is sort of asthma, COPD overlap, and the dotted line is COPD. And you can tell if you trace these backwards that the people that ended up with chronic respiratory disease, you could almost have spotted them at the beginning, suggesting that if you have risk factors for chronic respiratory disease early in life, that will track through your entire life. And that's the same for FEV1 and the FVC ratio, the amount of obstruction or tightening of the airways you have. So early life is important, and again, Rebecca will be able to show some of this. Not only that, but once you are adulthood and you have chronic respiratory disease going forwards, you're much more likely to pick up a whole lot of other diseases, even when you try and match and adjust for other risk factors and smoking and other things. Looking at diabetes, chronic cardiac disease, CCF, hypertension, a number of other comorbidities. The people that have an FEV1 predicted early in childhood go on to have many, many more and earlier comorbidities. So you can see this is people who've had good lung function, and this is people who've had poor lung function. And they get hit earlier if they have poor lung function, and they get more comorbidities and more risk of death. So it's complicated. I've shown you some data from almost all of these stages of life. And it's complicated because there's acute infection, there's, in our settings, malnutrition, other insults including HIV, smoking, household air pollution, and occupation, which I'm not even going to go near, that affect different times of life. And there's a relationship between chronic lung disease and acute lung disease, and all of these things need to be addressed. And I suspect a stove isn't as important as the whole of this, and that's with diluting the effects out. So I think what we've had is a problem where we've had a simplistic analysis of the problem. We've thought household air pollution's bad, let's sort that out, and come up with what's an elegant solution, but it's too simple, it doesn't work, and then we start again. There's many ways to make air quality bad, and many ways we'll have to improve it. Okay? So, are we guilty of too much optimism? I think you've probably heard what I'm trying to say. The stoves that we used in the CAP study in Malawi very quickly broke when they were in rural settings. They were not used for a number of reasons, mostly because by a year about a third stopped working, but also people just didn't like them as much. Or, when they did use them, they still liked that charcoal taste to the food, and they had another stove, and they used both. So it's complicated, and we shouldn't underestimate how complicated humans are. There's also a lot of alternative sources which we've not even tried to address yet. And the next iteration of an intervention study is going to have to address these. And I've talked about, well, maybe it's even just poverty or something surrounding poverty, and not necessarily the fire. Although I'm not sure I believe that myself. I'm sure it's all of these things working together. So, what can we do to improve it? Firstly, remember, interventions are only interventions when they're adopted. So, people didn't use the stove. And actually, I talked about the London smogs earlier in the UK's history. And the thing that sorted this out was government legislation, the Clean Air Act, and in the US, also the Clean Air Act, after similar sort of stories in California and other places, which promoted much stronger air quality legislation. Will these problems just go away? Well, this again is perhaps a little bit of a problematic analysis if you want to take it apart, but this is a global burden of disease figures. Each of these dots is a country, the red from 1990 and the blue from 2016. Let's take the central panel first. This is the socio-demographic index of the country, the GDP effectively. And this is the exposure to household air pollution. And if you wanted to overlay causality on this, you would say as countries get more or less poor or more wealthy, household air pollution stops being a problem. The same is not true for ambient air pollution and other sources. And you can imagine why that might be in terms of industrialization, cars, other problems that we have associated with that lifestyle. And tobacco smoking might even go the other way, at least initially, when people start getting a little bit of money in their pockets and they think it's cool to smoke. Will it go away? Well, can we do anything about it? So this is the time-weighted average of particulate matters 2.5, an annual figure, and this is between the periods 2005 to last year, really. Again, the Health Effects Institute from the State of Global Air, online data, and you can see that the global trend is really not very edifying. None of us are doing very well, and that's true of Europe, of the US, of many places, but it's not true of China. Why not? Well, there's a lot. For all people think that the difficulties of China have been related to economic expansion and unbridled economic expansion, they've been fairly good at spotting recently, or at least in the last 20 years, that they need to do something about environmental degradation. And that runs contrary to what you might read in some of the press. This downward slope in China has been associated with, but perhaps not caused by, huge injections of cash for urban settings. And this is the last 2 or 3 years now, $120 billion to the Beijing region to try and improve this. They've put prohibition, geographic prohibition particularly in urban areas and peri-urban areas. And they've done things that you probably wouldn't get away with in some other countries in terms of forcefully removing coal boilers from people's houses. People had a very cold winter before they managed to replace them with other things. But there's been direct and sustained and drastic action that has resulted in improvements. Whether we could do the same in other countries, I don't know. This is a similar kind of thing. This is proportion of population using solid fuels, and this is from 1990 going onwards. And this is by the socio-demographic index of the group of countries. Here we have high-income countries which are using less and less solid fuel, but you wouldn't notice because they weren't using that much to start with. High middle incomes, they're doing a good job of decreasing their solid fuel use, and the global average is just going down a little bit. But low income countries have a problem. They're stuck in this cycle, they're unable to increase drastically availability of electricity, to legislate effectively, and to say no to big business where they are happy to pollute and pay money for it. Will they go away? I'm optimistic that as we develop as a global economy over time into something a little bit more nuanced, that we might help. So, just a few closing words. I'm not going to spend too long. And it's a personal view. I think there's ample evidence that particulate matter is bad. I don't think it matters that we've not shown this for household air pollution definitively, or we've not shown the single solution. I think we need to be a bit more grown up about it. We know that multiple insults can mask a single source effect. Or maybe the effect isn't profound as suspected, but I think there's lots of things we can do about it. There's lots of things that will happen as a result of economic, quote, progress, unquote. And I don't think we need any more intervention studies of health effects for reducing household air pollution. I think we need to do something about it. And I think we need to have a complex look at the sources of air pollution in our communities. Household air pollution being one of them, but certainly not the only one. Traffic and other sources of carbon emissions are really important. And we should stop wishing, because it is a wish, that the simple things and the easy things will make a difference. I put this because, having said that I don't think any more intervention studies are needed, this is being done. I told you about the Ghana study of LPG gas. This is an even bigger study funded by NIH in 4 different countries, 3 different continents, which maybe will make me eat my words. Maybe I'll have to come back to you when they finish in 2022 and tell you LPG works. But in the meantime, I think we have to do something about the rest of of our mess. And I'm going to stop there a bit provocatively and ask you for any questions.
I saw one of the slides that Kenya showed a very big state. What did Kenya do to clear its air?
Well, the problem with this is that there is very little data, and the data that I've shown you is what's available. I heard from the inauguration lecture at the MLI earlier this year that I attended that there's pretty good and potentially quite robust air quality monitoring in Kampala, or there might be from the engineering department. I'm not sure that's rolled out yet, but what essentially happens is that US embassies hold the only key to monitoring air quality in any one African cities, and that network hasn't been built up. So the data that you're talking about that I showed you somewhere near the beginning of this is because there's so little data. There. That's the one you're talking about, isn't it? Yeah. So I think this is measurement bias, and you can see that there's very narrow confidence intervals, and that's because there was only one measurement.
Okay. I just have a comment. You said something about the data was just from one sensor per city, right? We actually do, I work for the airport project under the College of Computing and Information Sciences, and we actually do air quality measuring, air quality monitoring, and now we have about 60 sensors. So we are actually working to, the data is open source, so you actually.
Yeah, and so these data were from 2012. And they are opening up, and they're for sure. But still, you're doing extremely well here in terms of having those data available and open. I think there's a project in a reassessment of the availability of data. Still, in Malawi, I know that there isn't really any significant improvement. In Nairobi, where I was earlier in the week, I think there's starting to be some. But essentially, the global the international distribution within sub-Saharan Africa is still in very few hands. And I think the initiative you talk about in terms of opening up data sources and shouting, "We have some data," is a really great thing.
Yes, thank you so much, Jamie, for the wonderful presentation. I was a bit intrigued by the images that you showed, where there was a comparison between the parts of the world that are well lit with electricity compared to the other parts which, yes, and indeed the ones which are not really well lit with electricity tend to suffer with the burden of air pollution. And it looks like we are stuck in this vicious cycle of implementation strategies where the innovative cookstoves still need firewood. And cutting down trees is bad because then you remove the natural air filters. And it feels like we're going to probably harness on the other potential innovative ways of, say for example, if we tapped into solar technologies that provide cleaner fuels, that probably might go into balancing between sparing the trees and yet again protecting the masses against the dangers of this fuel. So probably even when we go towards the direction of LPG, it still is manufactured from somewhere which still pollutes the environment. Yeah, so perhaps interventions that probably look towards even cleaner sources of energy might be the answer for us.
So I totally agree with you, Wincy. I think that it speaks to the difficulty of getting air quality good enough. So not getting it from bad to mediocre, but getting it from mediocre to good. And that's where we have to be. And that will take huge innovation and effort. And you can start to see that other places that have the money are starting to invest in solar farms. Of course, you need money and sunshine, so Australia does quite well. It's starting to. I think Rwanda is the case in point in sub-Saharan Africa, actually, with their information drive, and I understand that they're moving in that direction. And the UK, well, I mean, they do have plenty of money, but they don't have the other thing. So there's other forms. I'm not entirely down on cook stoves. partly because we know that a short-term solution doesn't come quickly, it doesn't come with innovation, just has to be with the materials we have available to us. But I think selling it on this is a health benefit is the wrong sell. The sell is, you don't have to walk as far, you don't have to carry as much wood on your head, you spend less time at the stove, there's less environmental degradation, you're less likely to be affected by floods. You have trees in a better environment. There's so many things going for it, but we've not pushed it because we've been so caught up in the health effects.
Jamie, I'm just wondering about the pollutants. The PM2.5 probably is measured more frequently, but I'm just wondering what the effect of the other pollutant is on human health. I don't know whether looked into, or the PM2.5 simply a surrogate or something.
So going way back, I put up here, this is what the US EPA suggests that they measure and go into an air quality index, and it speaks to different pollutants having different kinds of emissions. So particularly the sulfur, nitric oxides coming from heavy industry and cars, respectively, and ozone coming from a mixture of all of these things. There's not one answer to this, but they do tend to cluster together. So worrying, I think, about which pollutant causes what kind of problem is perhaps going too fine. And one of the things that I think has limited the expansion of monitoring sites is that some monitoring people, particularly from the US, have said, well, you need to have all of these. That'll be $50,000 per station, please, for as a setup costs. Whereas actually, as you will probably be using, I'm not sure which device you are using, Purple Airs or Dylos or some other similar.
We have a couple of them. Start with manufactured air, of course. Then we have different sensors. We have the purple air. Then we have the brown air.
So I mean, some of those $250.
Most of the ones that are deploying are low cost. Then the high reference monitors are just used for calibrating.
Yeah, absolutely. And so people will tell you we need to calibrate it, and that's true. It's true of all science that you need to do it as well as you possibly can. But that's in tension with the need to get information to people to inform their actions. And in some ways, you know the advantage in being in a laboratory of doing a quick and dirty experiment that is a catalyst for doing the refined and important things later. Because if you don't start with something, you don't move on. And I think there's a really key part to this, that we should measure what we can and publicise the results to enable action and then to refine later. But you're absolutely right, the things do affect people differently.
Okay, any more comments? Yes.
Yes, thank you so much for this enlightening presentation. And from here, of course, science is telling us that air quality is becoming worse and worse almost every day, and cause a lot of problems to human health and of course mobility and mortality. You mentioned something about good environmental control, or one of the government in Africa, particularly Rwanda, is doing something which is good. I'm wondering whether it's something in one American copy. Could make other African countries or leaders say what that we need to do something about this, because nobody is fair, including as long as you are living in that country environment. So is there really something that we can copy from Rwanda that can influence other countries maybe in Africa?
I think, I guess the first observation is people don't learn very much from other people's mistakes. And we should try. And, you know, the UK and the global north have made many mistakes that you should probably learn from. And one is car traffic and lots of other heavy industries, and now needing to regulate those sooner rather than later. And then there's the innovation that I've talked about and you're alluding to. it takes a very brave politician to take an immediate financial hit for a long-term gain, and you don't find many of them around. And the other difficulty is that nobody sees the relationship until you show them a graph that air pollution causes them problems. They think they get pneumonia, they think they get respiratory disease over a number of years. That link isn't quite there. I think with climate change that might alter. I think there's probably a tipping point where people think all of this strange, rains that are in Nairobi at the moment that have never been known to be this early, people start to think maybe this is something real and different. But until it starts to affect you in a personal way, it's very difficult. But I mean, the solution for Kampala is public transport. That's simple, I think. Simple and complicated all at the same time.
Okay, I also have one. Maybe just to recap for me, I still didn't get clearly the graph study, the data study. What's the bottom line?
The bottom line is the results are not out yet. So the actual intervention of the LPG stove, they have the data, but I'm not sure I've seen it, or I'm sure I haven't seen it. And what they've published so far has been the descriptions around the mechanistic and the prenatal exposures and how that affects neonatal lung function. But they will be able to show whether the LPG stove on a per household basis has reduced pneumonias and reduced immediate complications in pregnancy and lung function in neonates. But they haven't done that analysis, or I haven't seen it.
So maybe this one is a comment about the clean cook stoves. Our massive paper about cook stoves is out, as we published maybe last week.
Right.
But we observed some benefit in the acute things. Probably need to add to the list of saving the forests and others. The wives had less red eyes, less flus in the children, sneezing, the acute effects, coughs. There was actually some of them significantly reduced. So those things, they may not have a big impact, but like you said, who doesn't want to have their wives with clean eyes and house? So probably that may try to save, one of the things to save the clean cook stoves. And like you said, they really make cooking good. From the field, probably we've had these stories. People who borrow, Shalini was the one who made this one. So we gave a stove to a home. Of course, we didn't give everyone. But now, when the other home they had visitors, people come and borrow the stove. Let me the stove, I have visitors, so I can look upon that. When the visitors go away, they take back the stoves. So that's one of them. Of course, this one is the USB, the one we showed. Yeah. That one was very popular. Everyone was going there to charge their phone and be happy. And then the full one, which they change, they put it like this, you put charcoal. The day you don't have charcoal, you turn it around, you put the fire. So all these engineering things, whether they have health benefits or not, probably if they make them rosy and looking nicer, maybe. So I wanted to know if the LPG will help, because recently in the clinic the patient put me to farm. This thing smells badly. You think inhaling that smell from LPG is safer than my fire would have tell me. Yes, I cannot, as I said, but the smell is just of the gas. But the particles are the same. Which particles? So, practical things.
So my understanding is the smell of LPG is not the gas itself, but it's the addition of a chemical so that you can smell gas leaks.
So they were worried. Any other comments?
Yes, I'm thinking about the statement that probably we don't need more interventions. And I'm thinking it's probably the kind of interventions we put out been very scientific and very medical. And maybe we need to approach it from a behavioral perspective, because cooking is a behavior. There are all these papers around why I would cook this food, things, why I don't like this, my husband, when I cook this. It has all the social things. And maybe the interventions have to cater the whole perspective of cooking as a behavior. That's one. But I was also wondering, how do people actually want an ordinary person will relate to this data you just presented? I think we could even start by ourselves here. How many of us think that data even concerns us? Well, how many of us are scared? Maybe we think it is somebody else.
Yeah.
Yes, it's air pollution, it's there. And for as long as we don't see the immediate effects, or we think it's very far away, maybe we may not even think about changing the behavior. And if I was wondering if there is something which I could just, maybe the science, design something I put in my house and really show me this is what is happening in your house. Because when you present it there, I will say it's just the American embassy, maybe it's the people in Namoko, around there. For me, I live the other side. And I can't relate to it that way. But if there is some small device, just to show you how bad it is, maybe it will stimulate people to just say, I'm badly off, I need to do something. We've done some sessions within the community in Germany where you can't imagine how husbands think they are not, the men think it's a woman's problem and they will cry. But they live in that same household, and yet, if it's something to do with women, maybe it's not very important, they won't do something. But if that gadget was there and they see it and they are also there inhaling that smoke, maybe it would make a difference. So, in terms of innovations, besides the cook stoves, I think something which can measure and I can purchase it and just show how bad it is might help children.
For that great presentation. I have one question goes to the lady from Professor Emerson. It's good, it's great that you're already doing the measurements, but what plans are you doing? Are you doing this and that analysis and trying to use this data to inform decision making? Related to what Rebecca is saying, you might not identify with these high levels elsewhere, but if you can have this, the measurements you're doing, and then they are shared and you can even use them to advocate for better interventions, engage government and parliament. This is the evidence that we need. The problem is to let people come up with interventions. Yeah.
Okay, yes, we work with several partners, including KCCA, and we are funded by Google, World Bank, Air Observatory, University of Sheffield. For us, mainly what we do is we have head of the sensors, the monitoring, the data analysis. We can actually get this data via an app. We have mobile apps on Android and iOS. We have a website. You can see this data in real time from several locations where we have a sensor. Yes, and then we work with those partners. Some of the partners like SCA and NEMA are responsible for they take the action. Although we still look for them.
Would you push and see how we can engage government using that data?
Yes, so KCCA and NEMA are present.
Thank you. Then the other question, I don't know how LPG is manufactured, but for example, in our setting, and I think the current evidence is saying that with increasing population, people are going to having more animal production. For example, they say cows they produce a lot of methane, and that has an effect on global warming. But this, the waste from such animals can be converted into gas that can cook. Can we move into such interventions? Using this animal waste?
Yeah. So we can, but as you imagine, it's a little bit messy. And it's been done in Kenya with methane sort of extraction devices. The problem is that the cattle, so one of the problems is climate change and cattle being responsible for 25% of the global warming. And it is the methane in their burps particularly. But capturing that when you have cattle outdoors is very difficult. So there have been, bags of methane that are stored up from closely covering cows up when they're asleep, for example. But non-commercial use of those technologies is very, very difficult. It is possible. It is possible. It's difficult to know whether it's scalable for the people who are. It doesn't have enough benefit, I think, for the smallholders that have small number of animals. But it may be that technology improves, and it may be that.
Okay. I just had one simple one. Okay. Now that you're doing this research, the heart of the planet, as the Pope described, the Amazon is up in flames. Do you think it's timely for you to inform decision using your research at the stage you are?
Yeah, there's some bigger people than me involved in that. I'm sorry to say. People have to start to listen, don't they? But I'll try and get them to listen to me.
Okay, I think we will stop here and let's start our presenters. And back to the coordinator.
So thank you, Jamie, for a great presentation, and thank you, Dr. Hans, for sharing this thing. Many thanks to everyone. And I'm just thinking, usually when we have these presentations, we learn people there with nothing. Either you think something that is going to improve you as a person. Maybe I'm thinking LPG and changing the way you cook your matoke and hello and things like that. And sister is saying, or you've learned something which you can share with your patients as they come with COPD, as they come with acute infections, what else they can do. So you can dig more into their history. These days people do very superficial history, but sometimes you just need to say certain things and then they say, oh, if I can do this, maybe it will be exacerbations and so forth. But also for the researchers, I am hoping we have identified research questions. This is really a very still gray, hazy area. You see the researchers are saying it does, others are saying it doesn't. Wherever we have people with conflicting ideas or conflicting or different opinions, that means that's a fertile research ground. And like we said, Uganda, if you live in Uganda, every day of your life, you know how committed you are. It doesn't matter whether you're going to your village, or you're going to here in Kampala, or you're going shopping, believe me, this bad air is with us. So I'm hoping that researchers have picked something and we can work as a team to come up with something. We have a research group within the London Institute, we call it the Air Pollution Group, headed by my neighbor on the right, Dr. Chimuli. So if you have any research ideas related to air pollution, please come and discuss. And any more presentations, any data if you want to share, we are really interested in sharing these things and see how we can try and contribute to the solutions to some of these problems. So once again, thank you so much. We have some soft drinks. They were cooked using LPG.